This is for Algebra 1. What we're looking at is graphing inequalities in two variables. The first video will just be basically the overview of what we're doing. The concept is that we want to first look at the linear equation. I did say equation there. And it will be presented either in standard or slope-intercept form. And you want to treat the inequality as if it were an equation so that you can first graph a line. And so that's what I'm going to write here, your first bullet. Pretend the inequality is an equation. Is it? Now the equation will be in the form of either standard or slope-intercept. And then the second thing that we want to look at, it's just basically an idea. It's the goal. On this section, what you're trying to do is find where there's overlap in the graphing. And so your goal is to find the region that has dual shading. Find region with dual shading. Now, I'm going to start off with just a real generic example, and then I'll do specific examples after this. So essentially, what we're going to do, we're going to look at having two inequalities that are in the form of lines. They'll either be in the standard form or the slope-intercept form. And so if I say something like this, if I say y equals 1/2 x plus 3, now that's an equation. We know that it says equals. The only thing that's going to change is I might say less than or equal to. So now it's still in the form of an equation, but it has an inequality there. And what you want to do is pull out a slope here, because of its slope-intercept form, is 1/2, and then a starting point. The starting point would be 0, 3. We want a nice place to start our graph. You put 0 in for x, you get 3 out for y. Now I'm just going to work with this one for a second. So if I have an xy plane, I start at the starting point. 0, 3 would be located about there. And then what we talked about in class is that we will be able to graph without a t-chart. So you find this starting point, and then you should be able to use that slope to find other nice points. With a slope of 1/2, remember slope is delta y over delta x. So it tells us how to move on the y-axis and how to move on the x-axis. With a slope of 1/2, it's telling me to go up 1 unit and then right 2, and that will find another point on the line. Up 1, right 2. So go up 1, right 2, boom, find another one. Up 1, right 2, find another point. Now, as I exhaust this line on the xy plane, I can go the other direction. You see what I'm saying is I got too far over here, I can reverse this. So instead of going up and right, I can go down 1, left 2. And there should be another point. Down 1, left 2, so on and so forth. Once you have these points in space, what we want to look at is whether we want to have an open or closed circle. And just like the inequalities we were doing previously, we were looking at inequalities like this, x greater than 5. That meant on a simple number line, we'd locate 5, we'd have an open circle and shade this way. Or we would say x less than or equal to 7. We'd have 7, we'd do a closed circle and shoot this direction, shoot off to the left. When I'm doing a line in the XY plane, I have to consider whether I want a solid line or a dashed line. Because this has equality in it, it has equals, I will make this a solid line just like that. And then I understand that it's an inequality, so I have a whole region that's being shaded. And the trick is to figure out what region is being shaded. So as I look at this, I'm going to test the origin. In other words, I put 0 and 0 in. Is 0 less than or equal to 3? True. Since 0 is less than or equal to 3, the region that contains the origin needs to be shaded. So I would shade off in this direction. Another example with this. Let me give you a standard form equation, do the same thing. We'll just run through this real quick. Let's add 3x minus 2y equaling 6. The very first thing I have to do is pull out a slope. From the standard form, you should be able to look at this and recognize that the slope would be 3 over 2 and make it positive. It's always the opposite of what's in there, so it's 3 over 2 positive. Slope, positive 3/2. I need to find a nice point. The starting point can come from either putting 0 in for x, see if I divide that I get a nice result, or putting 0 in for y. If I divide that, I get a nice result. Or sometimes you may have to use both of them and think about what combination would work for you. For this one, it's very straightforward. If I put a 0 in for y, I can get 2 out. So when I solve that, I divide both sides by 3, I get 2, 0. So I got a nice starting point. In terms of my graph, you have to think about what you're doing. A 2, 0 will be found on the x-axis. So I go right 1, 2, there's my starting point. Once I have the starting point, this is done. I go to the slope and I follow the slope. Knowing that the slope is delta y over delta x, it tells me how to maneuver. In this case, it's saying go up 3 units from your starting point and then right 2. So I go up 1, 2, 3, right 1, 2, put a point. From here, up 1, 2, 3, right 1, 2. And I can also go the opposite direction. The opposite of up 3, right 2 is down 3, left 2. Down 3, left 2. The difference on this one, when I come back up here, I know I had this as an equation. Let's pretend that it said less than. That's where we have to come back and employ the techniques for inequalities. If it's a strict less than, as we mentioned a moment ago, in 2 dimensions, that would be an open circle. In 1 dimension, it would be 1. On the number line, it would be an open circle. In 2 dimensions, it would be a dashed line. So I'm just going to make a dashed line here. It's the same idea as having an open circle. And then I check a point that's not on the line to see what direction I shade. So if I try the origin here, you're going to use the origin on like 99% of these. 0 and 0, 0. Is 0 less than 6? True. Since it's true, I want to shade that region. I'm just going to shade like this. And that's our introduction to how to graph inequality lines.